minimize z equals 2x plus 3y subject to x greater than or equal to 0, y greater than or equal to 0, x plus y greater than or equal to 3, x plus y less than or equal to 9, and x plus 3y greater than or equal to 6. So we're just going to put all of these lines on the graph, the boundaries, and then talk about these inequalities. So the first one we're going to do is x equals 0. Now we're going to do y equals 0. Now again, we're just creating the boundaries again for this. X plus y equals 3. The next one is x plus y is less than or equal to 9, or actually just is equal to 9. We're just doing the boundaries. And the last one is x plus 3y equals 6. So there's the last boundary. Now we're going to try to fill this in where it goes. So we know that x plus y has to be less than or equal to 9. So essentially, I'm just going to plug in 0, 0 for all of these if you don't remember. So if I plug in 0, 0 here, or I can't plug in 0, 0, I'll plug in 1, 1, which would be here. And I can see if that's true for all of these. So for the x, for this first two, it's true. For this one here and this one here, if I plug in 1 for my x, I'm going to get 1 greater than or equal to 0. I'm going to get 1 greater than or equal for my y. So that's going to be good for both of those. So that means it's on the right side of those. Now for the next one, 1, 1, that's not greater than the orange line. So that means I'm on the right side of the orange line. So I'll be over here somewhere. And again, I can keep stretching as far as I want. I just know that I'm on the right side of the orange line, or you could say above the orange line. I don't know how you want to word that. And then the x plus 9 less than 9 less than or equal to 9 there. So that would be 1 plus 1 here because I'm putting in 1, 1. So that's 2 is less than or equal to 9, which is true. And that's the green line. So that narrows me down even more. So I'm on the upper part of the orange line and on the lower part of the green line. So I'm in here somewhere right now. Now I'm going to do the purple line. So when I plugged in 1, 1 there, so that's going to be a 1 plus 3 times 1, which is 3. So that's going to be 4. 4 is not greater than or equal to 6. So that tells me then I wouldn't be on the left side of the purple line. I'm actually going to be on the right side of the purple line. So there's our feasible region shaded in, and now we're going to label the corner points, but I'm going to indicate them first. So there's our first one. There's our second. Our third is here. Fourth over here, and we have a fifth up here at the top. So those are our corners for our feasible region, and those are where our max or minimum is going to occur at one of those points. So now we're going to start to label our points. We'll start with this one here. This one is 6, 0. The next one is 9, 0. The next one is 0, 9, and that's up top. And then the next one there would be 0, 3. And the last point, we really can't tell what that is. We're going to have to pull those two equations out where those boundaries are. So that was the orange one and the purple one here. So I'm just going to write those two equations down below. So you have x plus y equals 3. And remember, it's equals because we're talking about the boundaries. And then the other one is x plus 3y equals 6. So now I'm going to use substitution here. So I'm just going to take this and solve it for y, actually for x. So I'm going to get x equals 3 minus y. So I'm going to take this now, wherever I see x in the other equation, and plug in 3 minus y. So I'm going to get 3 minus y plus 3y equals 6. And there's that piece, and that piece there. Okay, so now what I'm going to do is solve for y. So I can put these y's together since they're on the same side. So that's going to be 2y. So it's going to be 3 plus 2y equals 6. Move the 3 over. So that's going to be a subtraction of 3. So that's 2y equals 3. And then y is going to equal 3 over 2. And then we plug that in for x. And which one will I plug it into? I'll plug it into this one here. It'll be the easiest. So then x is going to equal 3. 3 minus 3 over 2. And that means that's going to be 3 over 2. So this is really 1 and 1/2. So if I do 3 minus 1 and 1/2, that's going to leave me with 1 and 1/2. So my x is also 3/2. So my ordered pair then is going to be 3/2, comma, 3/2. That's where those two lines intersect. And that's going to be this point here. So there's my point, 3/2, 3/2. So now that we have the corner points, we can now minimize the equation z equals 2x plus 3y. And that's what we're going to do now. So the first point we're going to pick is 0, 9. So that's going to be z equals 2 times 0 plus 3 times 9. And that's going to be 27. So the next point I'll pick is 0, 3. And that's going to be z equals 2 times 0 plus 3 times 3. And that's going to be 9. And the next point is going to be this 3/2, 3/2. And that's going to be z equals 2 times 3 over 2 plus 3 times 3 over 2. Let me fix my 3. And that equals 15/2. And the next point I'm going to pick is 6, 0. And that's going to be z equals 2 times 6 plus 3 times 0. And that's going to equal 12. And then I'm going to pick 9, 0 for the last one. And that's going to be z equals 2 times 9 plus 3 times 0. And that's going to equal 18. Now remember what we're trying to do here. We're trying to find the minimum. We're trying to minimize here. So the smallest value of all of these numbers is the 3/2, 3/2. And that's going to be the smallest because 15/2 is 7.5. So that's going to be the point that minimizes that equation, 2x plus 3y. So I would say 3/2, comma, 3/2 is where z is the minimum. There it is, done.